another set of video notes. Today we've moved on to 3.8 and we're going to learn how to use inverse matrices to solve linear systems, okay? But before we can do that, we need to even figure out what an inverse matrice is. So, remember the other day in class we started talking about this identity matrix? Remember, like, the additive identity for numbers is 0 because you can add 0 to anything and it stays the same. Well, this is the identity matrix for multiplying, because if you multiply any matrix times the identity, you just get it back. Okay, you get the same thing. So also remember that, let's talk about multiplication. There's such a thing as an inverse, because if you multiply a number times its inverse, you get the identity. Now, what's the identity for multiplication? It's 1, right? Because 1 times any number is itself, is just that plain number. So we need to figure out a way to get the inverse. In multiplication, we just divide, right? Well, of course, this is a little more difficult. The other day somebody said, are we ever going to divide matrices? This is kind of like dividing, but that's too difficult. So we're going to do just finding an inverse instead. Okay? So this is probably a great thing to get on your cards. If you start out with this matrix, it's a 2 by 2, and that's pretty much all we're going to limit ourselves to. If you want the inverse, you do 1 over the determinant, which we just learned how to do. And then notice A and D swap places. C and B stay in the same places, but now they have a negative in front of them. Think of that, and I'm going to write it just to help you remember. Think of that as opposite, not negative, but the opposite of whatever was there. So, I did kind of give you a hint on determinant if you don't remember. That's just doing the diagonals, A times D minus B times C. And we're going to multiply that determinant under 1 by each thing. So let's go through and try it. Okay, here is our matrix. It's a 2 by 2, and we've got 5, -2, 8, and -3. So the first thing we need to do is figure out the determinant. Well, that's going to be 5 times -3, and from that we're going to subtract 8 times -2. Okay, well, let's do a little more work. 5 times -3, that's -15. 8 times -2 is -16, -15, plus 16. Hey, that just becomes 1. That's easy. So now we've got 1 over 1, and now we're going to do all our little changes. Remember, on this diagonal, they switched spots. So we've got -3 comes up there, and 5 goes down there. And remember, what is the opposite of -2? It's just +2. What's the opposite of 8? -8. And if I multiply what is 1 divided by 1? Oh, it's just 1? Oh, so multiplying by 1, that's easy. It is just 1, and you have just found the inverse matrix. Okay? Or matrice, I should say. Matrix, I guess, because it's singular. Okay? Pretty good? Let's do one more example. We have another one over here. Here's our A, and our B, and our C, and our D. So the first thing we need to do is come up with the determinant, which, remember, is the same thing as saying AB minus BC. So let's try that. Let's see, A times D, -3 times -2. And we're going to subtract from that B times C, which is -4 times -1. So let's see, we get -3 times -2, well, that's a +6. We get -4 times -1, that's a +4. And we're going to subtract between them. So the number out front is 1/2. Now we got to finish this off. And remember, which ones are we going to switch? Oh yeah, the ones right here. So -2 comes up here, -3 goes down there. And then these, we take the opposite of. So what's the opposite of -4? Positive. What's the opposite of -1? Positive. And now this is that scalar multiplication, so we're going to take half of each one of these. And we get Half of 2 is negative 1. Half of 4 is 2. Half of 1 is 1/2. And half of negative 3 is negative 3/2. And you found the inverse and you're done. Okay? Now some of you might be thinking, well, that's lovely. Who cares? Well, but we can do something with the inverses. So let's go on to that part. Okay? And it's called solving matrix equations. Okay? So I've got a matrix on this side. It's multiplied by x. And I've got a answer matrix over here. Well, let's think about this. If I could multiply this one by the inverse, then it would be gone and I'd just be left with x. Well, what you do to one side, you have to do to the other. So I need to multiply the inverse times b. Oh, and that will give me the solution. So that's what we're going to do. We're going to first have to find the inverse of a. Okay, so let's first do our cross multiplying. And we get negative 4 times 6. And you get 0 times 1. And you're going to subtract between those. So what is negative 4 times 6? Well, that's negative 24 minus 0. Wow, this looks ugly. Negative 1 over 24. This might be yucky. Okay, well, let's wait and see. So that's our first part. Now, we need to swap some numbers around and get our matrix. Okay, so we switch the spots here. 6 comes up, negative 4 stays down. And what do you do with these? Oh yeah, change the sign. So this becomes a negative 1, and this becomes negative 0, or just 0. And now we're going to multiply. So we get negative 1 over 24 times 6. Well, that's like negative 6/24. Or in other words, negative 1/4. Negative 1/24 times negative 1 is a positive 1/24. Negative 1/24 times 0, well, that's easy. That's just 0. And negative times a negative is positive, and you get 4 over 24, which equals 1/6. Well, that's a little messy, but we'll work with it. So we found our inverse matrix. Okay, so now what we're going to do is we're going to multiply that by b. Okay, so here we go. Our inverse was negative 1/4 and 1/24 and 0 and 1/6. Our regular matrix is 8, 9, 24, 6. Okay? And sometimes it's almost easier to just keep it as the original fractions. The numbers get bigger, but it's okay. So here we go. We're going to multiply them. Now this is back to our matrix multiplication. So this is a 2 by 2, and this is a 2 by 2, this is a 2 by 2. So we know our answer will be a 2 by 2. Okay, so we're going to have a first row, all our spots. Okay, so now we started doing that circle thing. That seems to help some of you. So let's go ahead and do that. So this spot is first row, first column. So we're going to take negative 1/4 times 8. And we're going to take 1/24 times 24. Well, those aren't so bad because that becomes negative 2 plus 1, which is just negative 1. That one turned out pretty nice. Okay, let's go down here. This is the second row, first column. So second row is right here. And we're going to do 0 times what? Oh yeah, times 8. And then we're going to do 1/6 times 24. Well, let's see, that's 0 plus 4. Oh, so that turned out okay. That's just 4. Let's come over here and do second row. Yep, second column. Thanks for helping me. Oh no. Oh, Mrs. Roth, get it together. First row, second column. And what about this spot? Yeah, this is going to be our second row, second column. Thanks for catching me. Okay, so first row is right here. And then we're going to go negative 1/4 times 9. Well, that seems yucky. And then we'll have 6 and 1/24. Okay, well, let's see, negative 1/4 times 9. Let's just do it this way, negative 9/4. Isn't 6/24 the same as 1/4? Oh, yeah. So that's like negative 8/4. Hey, it came out okay. It's just a negative 2. All right, let's do our last one. We've got second row, second column. So what are we going to multiply the 0 by? The 9. And what are we going to multiply the 1/6 by? Oh, 6. And we get 0 plus 1, 1. So that turned out really easy. It's negative 1, negative 2, 4, and 1. Okay, let's do one more example of this, and then we'll probably come to class and do practice. Okay, so here we go. We've got our A, and we've got our B. Okay, we need the inverse of this, so let's do that one first. Let's do determinant. So we've got 1 over 3 times 5, and then we've got negative 7 times negative 2. We're going to subtract between these. What is 3 times 5? Oh yeah, 15. Negative 7 times negative 2, ooh, 14. Oh, sweet. When you subtract them, you just get 1. Well, that's going to be easy. Okay, now we need to switch our spots around. So which ones switch? Oh yeah, 3 and 5. So 5 gets to come up, 3 has to stay down, or move down. And what do we do with these? Oh yeah, you take the opposite. So instead of negative 2, the opposite is positive 2. Instead of negative 7, the opposite is 7. Now what's going to happen when I multiply everything by 1? Oh, Mrs. Roth, it's so easy. It stays the same. Okay? So our inverse matrix is just 5, 2, 7, 3. That's our inverse. And if you remember, what we need to do is take that times our matrix B. So we've got 5, 2, 7, 3. And we're going to multiply that by negative 2, 4, 3, and negative 1. Okay? So, here we go. We're going to do, let's talk some more. Let's move on. This is a 2 by 2. This is a 2 by 2. So our answer is a 2 by 2. And we're going to have all these spots. And now let's try to name them. This is a part of which row? Row 1 and column 1. This is a part of the second row in the first column. This is a part of the first row, second column. See, I did learn from last time. And this is second row, second column. Now, some of you seem to like this, so circle the rows and circle the columns. And here we go. So first row times first column. So we get 5 times negative 2, and then 2 times 3. So this is negative 10, this is 6, we add them together, we get negative 4, okay? Let's go down to this one, second row, first column, so you do 7 times negative 2, and you do 3 times 3, that's negative 14 plus 9, which is negative 5, okay? First row, second column, 5 times 4, and 2 times negative 1. So you get 20 minus 2, that's 18. And our last one, second row, so now we move here, and we still have these numbers. 7 times 4 plus 3 times negative 1, get 28, plus a negative 3, which is 25. And that's your solution, and we will practice it some more in class, so I will see you later. Bye.